class. Today will be our final lesson for Chapter 8, and that is where we're going to be comparing different forms. So if you look at the paper here, across the top we have the three forms. So we have linear, we have exponential, and we have quadratic. Now quadratic is what we were doing here in Chapter 8, where we taught you the three different forms. So you learned standard, you learned vertex, and you learned intercept. So we're going to be kind of using some of that today. We won't go too in depth, but we'll be using some of it. So just kind of a quick review. A linear function is if the graph was a straight line. So if you can just imagine you've got a straight line, and so that would be our linear. So the equation, we have two of them technically that we use for linear, but probably the easiest is just to use y equals mx plus b. So what you're going to be doing today is you're going to be looking at different sets of data, and you're going to have to determine what these are. So you're going to have to determine, like, number one, is it linear, exponential, or quadratic? And so just kind of having this idea of what the graph looks like is helpful. And then also you will be writing the equation. So that's why I'm just kind of reviewing the equation with you. So here's linear. Now we do have point slope, but in today's lesson, they always give you the zero spot. So in every single one of these, if you notice 0, 0, 0, they're giving you the zero spot. So this would just be our easier choice. All right, exponential. Exponential we learned in Chapter 6. Now there's two types of exponential. There's exponential growth and there's exponential decay, but I don't want to confuse you, so I'll just draw the one picture here. Sorry, I forgot to draw that in red. So that's just the picture. That would be exponential growth, but decay would start up high and go this way. But it's not a big deal. You'll see how it works. And then the equation is y equals a times b to the x. Now sometimes you might forget what these letters represent. So a is the y-intercept. So that's like the 0 comma number. And b is what they call the ratio. Now, I usually call that the multiplier. So it's like, what are you multiplying by? Are you multiplying by 2? Are you multiplying by 3? What is the common multiplier? So that's the two positions, and then the x stays as part of the formula. So you always have your two letters. Now, quadratics are what we've been learning in this chapter. And so there's lots of different ways to draw a quadratic, but if we just draw it like this, okay, there's three different forms. And so just to kind of review, you have standard form, that's the ax squared plus bx plus c. Okay, notice there's no parentheses, that's called standard. Then we have vertex, that's the one with the h and the k. And so we can pull our vertex out as h comma k. And then we also have intercept, and that's the one with the p's and the q's, okay? And remember, we use our little formula to give us our axis of symmetry. Now, we are actually not going to be going and doing these ones today, so writing these three is actually going to be our extension lesson. And I'll talk more about that at the end, okay? So we're actually not going to be doing these today, even though you do know how. We thought the lesson might just get a little bit too long. So down here in this box, and this is just copied right from your textbook, but so if you can't see it, you can always go online as well, or look at my hard copy notes. But in here, it tells you how to find the differences. So if we look at linear, linear is going to have that constant change. So it's going to have that constant slope, you know, the rise over the run. With exponential, we're going to be looking for a common ratio. So we're going to be looking for that common multiplied number. So like, what is it going up or down by? Now, quadratics are a little bit harder to identify. So notice it says the second differences are constant. I'll show you an example so you'll be able to see that, but that one is harder to identify. Now, the nice thing in our class is you only have three options. So you can kind of use process of elimination. If there was a choice of neither or like none of the above, now that would make it quite a bit harder to see the quadratic. But in ours, there's only 3 options. So let's give it a try. We have 6 problems here. So notice there's just 6 of them. And what you have to do is tell me what of these 3 types it is. And then if it's linear and exponential, we want you to write the equation. But you can skip the equation if it's quadratic, because that will be our extension lesson coming up tomorrow, okay? So let's take a look at number 1. So you have your x's and your y's, and if you wanted to, I know you don't maybe probably have graph paper there, but you could, draw yourself a rough sketch of this if you wanted, like -1, 3, 0, 6, 1, 12, 2, 24. And so what you'll kind of notice is sometimes it can be hard if you don't use real graph paper because it's hard to tell if they're straight or not. But what you should be noticing is it's kind of curving up very quickly. Notice at 2, you were up 24, and look at 3. 3, you're way up at 48. So see how it's going up quite quickly. That should hopefully give you an idea of what the correct answer is. But if you're still not sure, take a look at the x's. They're going up by 1, which is great. So the x's are going up by 1. That's perfect. Look at the bottom. This is going up by 3, up by 6, up by 12. Whoa, that's not linear. But we should notice that it's multiplying each time by 2. So see how it's times by 2, and then 6 by 2, times by 2, times by 2. So this multiplication tells me that it must be exponential. Now, using our formula for exponential, I'm just kind of recopying it so you can see it here. Remember, A is the y-intercept, so that's our 6. So we're going to put the 6 in place of the A, and then the B is the ratio, like what are you multiplying by? So we're multiplying by 2, and then we raise that to the x. And then this would be our answer, along with the word exponential. So those would be the 2 pieces that they're looking for, okay? So first thing you want to do is identify what it is, and then if it's linear or exponential, you want to write the equation. So let's try number 2. Notice down by 3, actually no, let me do the x's first. Up by 1, up by 1, up. So this is looking good. This is going up by 1. Notice on this one, it's going down by 3, down by 1, and then notice it goes up 1. So this is clearly not linear. And now let's look and see, is it exponential? Is there anything that I can multiply by? And you're like, no. So we've ruled out linear. We've ruled out exponential, so then our only option left is quadratic. Now there's 2 things I want you to notice with quadratic. Do you notice how it's going down and then it goes back up? So if you kind of envision a graph at -3, 4, 2, 1, -1, 0, and then it goes back up. So out of our choices, something that goes down, turns, and goes back up must be quadratic. The other way I want you to notice it is look for symmetry. Do you see how it's 4, 1, 0, 1, 4? Do you see how this middle point, and then do you see how it's kind of balanced on each side? That's your turning point. That's your vertex due to the symmetry. So if we wanted, our easiest way to write the equation would be in vertex form. And so in the extension lesson, we'll talk more about this. Plugging this vertex of h and k in is not too hard. It's getting this a value that requires a little bit of work, okay? The other thing I want you to notice is based on the definition here, it says the second differences are constant. So let me finish this off. We knew this was going down 3, down 1, up 1, and then this was up 3. So we definitely can see a little pattern there. But also, take a look at the second row of differences. So from -3 to 1, do you see how this is going up 2? From -1 to 1, up 2. 1 to 3, up 2. Do you see how this is the second row? So up here in the definition, it says the second differences are constant. That right there fits the definition. This definition is going to be a little bit more important once you guys take Algebra 2. In Algebra 2, you have more than just 3 options, and so then process of elimination doesn't work so well. But for right now, just kind of giving you guys a little bit of an exposure, and so process of elimination works just fine. Now, you might be able to guess by process of elimination, we've done exponential, we've done quadratic. There's only one more option left, but let's take a look at it. If your eyes do not like the way this is written, you can always rewrite it into a table. Some people really like the table form because it just helps their eyes in their mind process it. So you can change this, negative 1, 2, 0, 3, 1, 4, 2, 5. Okay, now let's look at the x's. Up 1. Yep, that's looking good. Up 1. Let's look at the y's. Up 1. Up 1. Up 1. Hey, this is looking good too. So do you see how it's constant? That would mean it's linear. Now, because it's linear, we can write our equation in y equals mx plus b. So we know the intercept is the 3. So we know we have the intercept of 3. And now we need the slope. Remember, the slope is the difference of the y's over the x's. So it's the difference of the y's over x's. So technically our slope is just 1. And if you don't want to write the 1, you don't have to. But I will tell you in this next row, the slope is not 1. So make sure you're calculating that out. So why don't you pause the video here and try these 3? You know there's going to be one of each. It just depends on the order. And if you're having a hard time seeing him here on my projection, then go ahead and you can pull up the copy of the notes, a blank copy of the notes, and you can look at it that way too. But go ahead and give them a try. All right, I hope you paused the video and tried it. Now number 4, I want you to notice you go from 11 down, back up again. So this is going to be your turning point, which means this is quadratic. And so if it's quadratic, remember, you don't need to write the equation right now. All right, number 5. Again, if you don't like this, you can easily redraw it. So I'm just reordering my numbers. Need to add one more. There we go. All right. X's, up 1, up 1, up 1, up 1. This is looking great. Up 1. The next one, up 2, up 2. Hey, this is looking good. Up 2. So this must be linear. Uh-oh, we do have one small problem, but it's not too bad. Where in the world is my y-intercept? They don't give me the 0, do they? They don't give me the 0, 1. But how about we find it? So how about we just back up this pattern? Why don't we make this a 2? We'll make this a 1 and make this a 0. And let's just continue the pattern in the other way. We know the pattern is going up 2. So if we just subtract 2, so 5 minus 2 would be 3. 3 minus 2 would be 1. And 1 minus 2 would be negative 1 minus 2 would be negative 1. I had to think about it for a second. So now I have found my intercept, okay? So I've got my intercept of minus 1, and now let's look at our slope. Remember, the slope is the y's over the x's, so that's 2 over 1. And there's our equation. So if they don't give you the intercept, that's okay. It wasn't too hard to just do the pattern in the opposite direction. But in our class, they don't give us, if this was way out to be at like spot 30, then it would be really difficult. But all of your examples in this class, they all are very, very close to 0 if they don't give you the 0, okay? Now again, by process of elimination, you can probably guess what the third one is. Do you see how this is quadratic and linear? We wanted to give you an example of each one, but let's go ahead and give it a try. If we look at number 6, notice we're going up by 1, so these are looking great. Notice the y's. We're going down by 8, down by 4, down by 2. So I know it's not linear. And notice it's going down, 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 down. So it can't be quadratic because there's no turn. So I know it has to be exponential. And so if we use our formula, remember A is your intercept. So we use the 8 as our A. Now be careful here. This has to be a ratio. So in your head, if you're telling me to divide by 2, I can't use division. I have to make this multiplication. So what would be the same thing as multiplying by a half? So I'm just going to put a half here. And so 8 times a half would get me the 4, and so on, okay? So here's my equation. So that concludes our chapter 8. Now, tomorrow, so the next lesson, we called this a wrap-up day. So we wanted everyone to have a little bit of time to play catch-up and get things done that they needed to. If you're done with chapter 8, so if you're all done, and you would like to go a little bit further in exploring how to write equations for one like number 4. So how in the world would I turn this into an equation? I know my vertex, which is an H and K, but how do I find the vertical stretch or shrink? How do I get that number? We have one more lesson here that we called an extension. Now this lesson is not required, but for many of you who plan on taking the regular Algebra 2, not the technical Algebra 2, this lesson is going to be very important. We are not going to do an exit quiz, so it's just simply go through the notes and practice some problems. All right, that wraps up chapter 8.